Welcome to Lecture 6 of our series on prosody. While pitch is important, which is why we devoted 2 whole lectures to it, prosody is far more than just pitch. This lecture and the next will cover the other main prosodic features. So, recalling our definition, in this lecture we'll cover loudness, timing, duration, and rate, which you also find in music, and also a few other things. We'll start with loudness. If we try to build out our table from the last lecture, loudness, the perception, can be approximated by log energy or log intensity. In terms of articulation, one way to make sounds louder is with more airflow. So if you're up for some fun, you can ask someone to produce a consonant sound, like ah, then give them a stiff hug from behind. Force some extra air out from their lungs through their larynx. What happens? Here, let's try it.
No.
All right, yes, the volume increased, sure. In Pratt, the volume can be seen in the green line. Now, actually, the effects of the squeeze are pretty minor compared to a lot of other things that affect the volume. Digress here a little bit. You probably noticed also that the squeeze caused the pitch to go up too, actually a lot more. Here's that sound again. Okay, it kind of makes sense, right? So more airflow can cause a faster vibration. Pitch and energy correlate as a default. Of course, it's under conscious control, but there is a correlation, and we'll talk about that more later. Microprosody was an issue for pitch. It's also an issue for loudness. So look at this crazy little line here, up and down, up and down. What's going on? If you listen to the sound, I don't think you'll hear quite so much variation.
Speech prosody.
Right? So you can hear the stressed syllables, right? But it's not as crazy as it looks here. What's going on? Of course, it's the consonants and the vowels. Vowels are louder than consonants. Some consonants are stops, causing almost complete closure. It makes things messy. Later we'll talk about ways to compensate for that for analysis. Now, the other properties of music that are relevant to speech are those relating to timing. So rate, so we have perceptions of how fast people are speaking. That tends to correlate with syllable rate, or the phoneme rate, or the word rate to a first approximation over enough data. We can measure the segment or the word durations. We can measure pauses, very significant. Log scale may be more appropriate. Again, microprosody is an issue. So consider the words peach and pitch. So peach is a lot longer. That's so interesting in terms of the phonetics of the vowels, but if you're interested in what speaking rate means in terms of communicative function, that's just a nuisance. So again, microprosody is there to haunt us. All right, next something a little bit different, articulatory precision, which can range from highly articulated or enunciated to very reduced. So looking at our head, focusing on the tongue. So the tongue is mostly what's involved here. So if I produce a sound like a-ta-ta-ta-ta-ta, the tongue is doing things towards the front of the mouth, the first blue arrow. If I'm producing ak-ak-ak-ak-ak, the tongue is doing things towards the back of the mouth. Okay, so the tongue moves around and produces sounds. If I say the word articulation very carefully in a precise, enunciated voice, then the tongue is hitting all of its targets very carefully, very precisely. If we've already been talking about this for a while, I'm just saying, articulation is important. If I mumble the word articulation, the tongue is not doing its job in terms of hitting the precise targets, but that might be appropriate if the word is known or predictable or unimportant in the context. Right. We'll see later that the distinction between careful articulation and reduction is relevant for turn taking and other functions. All right. So yeah, this just says what I just said. Microprosody is again a big issue, no surprise. Our next topic is nasalization. This is only borderline prosodic, but at times it's relevant. So the articulatory mechanism here is the velar flap. So there's a little flap of skin, not skin, of tissue, way back, farther back than you can reach with your fingers, that can either go up or down. If it goes up, it shuts off the nasal passages. If it goes down, it allows the air to go out through the nose. All right, so here's an example of something that has a lot of nasalization happening. Nya, 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 nya. Okay, so of course the N sound is nasal. It has to be. So this is linked to phonemes, but it's also suprasegmental. So the nasalization continued all the way to the end. Like that's why I stretch it out so you can hear it. So even for pure vowels, there can be some nasalization present. Let's listen to the end of that again, and then to something without nasalization. Okay, nasal. Less nasal. All right, nasalization has some interesting functions, but for now we'll just summarize that the articulatory mechanism is the lowering of the velum, and it can be detected by fluent shifts. All right, so in this lecture we've discussed loudness, various timing properties, articulatory precision, and nasalization. In the next lecture, we'll dive back down the throat to visit our old friend, the glottis, and we'll discuss different phonation types. And that'll wrap up our discussion of the components of prosody.